perpendicular distance. Perpendicular distance of a point from a line. The perpendicular, I'm taking the paragraph. The perpendicular distance of a point P whose coordinates are x, y, from the straight line AX plus BY plus C is equals to 0 is given by D. D is equals to the absolute value of AX1 plus BY1 plus C over the root of A square plus B square. This is the absolute value. Please, I beg your pardon, this is x1, comma, y1. That is the perpendicular distance of a point P whose coordinates are x1, y1 from the straight line AX plus BY plus C is equal to 0 is given by D. This D is representing the distance. D is equal to the absolute value of AX1 plus BY1 plus C over the root of A square plus B square. Where A, B, and C are the coefficients. The coefficients and constants of the general equation of a straight line respectively. Now, in the Cartesian coordinate system, you have x and y axis. You have x and y axis. You have x and y axis. That is x-axis, which is known as the abscissa. This is your y-axis. This is the origin. Now you have a straight line making a double intersect. Double intersect in the sense that the line is crossing both x and y axis. So now, if you have a point P here, you have a point P in this Cartesian plane here, point P. Let the coordinate of this point B be x1, y1. So we are saying that the perpendicular distance between this point P and this line, which is also the shortest distance, that is the distance between this line and this point P, for it to be the shortest one, it must be perpendicular. That is what we are saying. So we have this so now this is at right angle here. So that is so now the general equation of this very line is ax plus by plus c is equals to 0. It's equals to 0. So now, so what we're saying is the distance between this point P and this, maybe let me call this one the foot of the perpendicular. So that's PF. Right, so if D is the perpendicular, distance of the point P, whose coordinates are x1, y1, from the line ax plus by plus c is equals to 0, then my d is equals to the absolute value of ax1 plus by1 plus c over the root of a square plus b square. This is what I'm saying. So now, this is that. This is D here. That is D. The distance between P and F. Where this D here is equals to line segment PF from the diagram. So, now I take an example. Or before the example, now, what can we say about the distance from the origin, the distance between the origin and the line? If the point px1, y1 is located at the origin, then x1, y1 is equals to 0, 0. It's equals to 0, 0. It's equals to 0, 0. Equals to 0, 0. Let me call this one equation 1. Equation 1 is equals to 0, 0. Hence, the above equation 1 reduces to D is equals to the absolute value of c over the root of a squared plus b squared. Call this equation 2. Why? If xy here, if the value of xy here is 0, the value of xy here is 0, a times 0 is 0. If the value of y1 here is 0, b times 0 is 0. So, these first two terms disappear, and we are left with c. That is why it reduces to c over a squared plus b squared, where a and b are the coefficient of the variables, that is x and y, in the general equation of the straight line. Example number 1. Let's take an example. Let's take an example. Calculate this one. So, example 1. Example 1. Find the length. Find the length of the perpendicular. Find the length of the perpendicular from the point P24 to the line 3x plus 4y plus 6 is equals to 0. Is equals to 0. Is equals to 0. I read the question once again. Find the length of the perpendicular from the point P24 to the line 3x plus 4y plus 6 is equals to 0. This is the equation of that straight line. Now, solution. Recall that the general form of the equation. Recall that the general form of the equation of a straight line is ax plus by plus c is equals to 0. This is the general form of the equation of any straight line. Comparing the given equation. Comparing the given equation with this general form, we have, if we compare this given equation, 3x plus 4y plus 6 is equals to 0, with the general form ax plus by plus c is equals to 0, we have a to be equals to 3. A equals 3, b equals 4, and c is equals to 6. Now, Px1, y1 is the same thing as this P, or let me just go straight by saying that in this case, our x1, y1 is equal to the given point 2, 4. The given point 2, 4. The given point 2, 4. So all we have to do is we just plug in these values in the formula in equation 1. Substituting these values in equation 1, I have my D is equal to the absolute value of that is AX1. Let me recall the formula once again. AX1 plus BY1 plus C over the root of A square plus B square. So that is equals to A in this case we said is 3. X1 is 2 plus B in this case is 4. B in this case is 4. Y1 is 4 plus C in this case is 6 over the root of A square, which is 3 square, plus B square, which is 4 square. So this is what we have. So simplifying, B is equal to the absolute value of 3 times 2, that is 6, 4 by 4, that is 16, plus 6 over the root of 3 square plus 4 square is 25. 6 plus 6, that is 12. 12 plus 16 is 28. So D is equal to the absolute value of 28 over the root of 25 is 5. So D is equal to 28 over 5 units, or 5 in 28, that is 5 to the 5th units. So this is the length of the line. I'm done.